Let's run through an example. Now, in case you're wondering, these are fishing nets. A small fishing net, a big fishing net, and a larger fishing net. And I'll explain the analogy in a minute. Okay, so let's just say that we sampled from a population, and X bar, the sample mean, right? The sample mean is 30. And we calculated S sub X bar, so we estimated SEM to be 5. All right, now let's draw a 95% confidence interval around this mean. So what we need to do is look at our formula. We take X bar, in this case 30, and then we're going to add and subtract something from that mean of 30 to get the confidence interval, right? The lower and upper limit. Notice that X bar is always going to be right smack in the middle of every confidence interval. If for some reason it's not, it means you've made a calculational error because you're adding and subtracting the same amount from X bar. So that means X bar will always be smack dab in the middle of your interval. All right, so because we want the 95% confidence interval, we're going to use 1.96 as our Z-score, and S sub X bar is 5. So let's go ahead and do the calculation. So we have 30 mean minus whatever this turns out to be. So you're going to have to multiply this together first, get your answer, and then do 30 minus this product. We call the answer to a multiplication, remember, we call that a product. So 30 minus this product, and that will give you the lower limit. At the upper limit, it's just 30 plus this product, the multiplication of these two things, and that gives you the upper limit. And then we just write, we would write, I don't have it here, but we would write mu, put that in the middle, is somewhere between 20.2 and 39.8. So we would put mu and then the less than equal to greater sign. And on the other side of mu, we put, again, the less than equal to, and this one over here would be greater than equal to. Sorry for the confusion there, folks. Okay, so the one beside the lower limit is saying greater than or equal to 20.22, and the other one on the other side of mu is less than or equal to. So you're saying it's between these two numbers. And if we were to look at this interval size, we would say it's 19.6 points. And I just found that by subtraction. So you take the upper limit minus the lower limit, and it's 19.6. Okay? Now, what would happen if instead we wanted to calculate the 99% confidence interval? And here's where the fishing net analogy might come in. So let's say you want to net a fish, and the fish is quite large, all right? If you use this medium-sized net, well, there's a good chance you're going to be able to catch that fish, right? But the fish is a little bit bigger than this net, so there's still, you might not. If you want an even greater chance of catching the fish, you're going to need to use a larger net. Now let's relate this to confidence intervals. We're trying to capture mu, okay? Not the fish anymore, but mu, all right? If we use the 95% confidence interval, 95 times out of 100, we're going to catch mu. But if we want to be 99, if we want 99 times out of 100, we're going to catch mu, doesn't that mean we should use a larger net? All right, same thing here. This would be the 68% confidence interval. All right, if we use the 68% confidence interval, then we're using a small net. That fish is much larger than this net. It could get away. If we want to increase the chance of capturing the fish or mu, we got to use a larger net, and this one would be larger still. So the 68% confidence interval is this small net, 95, 99. So what do you think is happening to the size of the interval as we go from 68 to 95 to 99? Well, if you want a greater chance of capturing mu, the interval size needs to get larger, needs to be larger. So here the interval size would be pretty small. Here the interval size is going to be bigger, and here it's going to be biggest of all. Here's where you have the greatest chance of actually capturing mu. So now let's see that in action. So we calculated the 95% confidence interval for a mean of 30 and an SEM of 5. Let's do the same thing, but this time we're going to use the 99% confidence interval, which means we're going to have to use the z-score 2.58. Lower limit will be 30 minus, again, the product that you get when you multiply these two together. So the only difference here from the example above is this is 2.58. The answer we get is 17.1, so that's the lower limit. The upper limit is 30 plus the product. All right, that will give you the upper limit. 30 is the mean, x bar. And then when you add, this to the product, you get 42.9. So now we're saying that mu is somewhere between 17.1 and 42.9, and 99 times out of 100, this would have been drawn correctly, and in fact, mu is somewhere in this interval. Notice what happened to the size of the interval. So when we were calculating the 95% confidence interval, it was close to 20. When we calculated the 99, well, we want more chances of being correct, so we're going to have to make the interval size larger, and you can see it went up to almost 26. So now you should be able to tell me, how would the interval size compare if we were using the 68% confidence interval? All right, and that means a smaller net, right? We're only saying 68 times out of 100 will capture mu. So the interval size for the 68% confidence interval is going to be the smallest of all. All right? So maybe it would be, I don't know. I could do the math, but I won't. But maybe it's like 15 instead of 19.6 or 25.8. All right. Let's look at something else. What if we kept the confidence interval the same and instead varied the sampling error? What would happen to the intervals? So let's see, let's do this and see what happens. And then I'll explain why this graphic here. All right, so again, the data is this. You have a mean of 30, x bar is 30. Estimate of sampling error, SEM, is 5. We want the 95% confidence interval. We use this formula. We're going to assume we have a sample size greater than 30. This is just a coincidence, by the way, that the sample mean is 30. That's pure coincidence. So we're going to do the math like we did on the previous slide, and we say that mu is somewhere between 20.2 and 39.8. Okay, and here's the size of the interval. So that we've already done. Now let's switch it up. Let's say, what if the mean was 30, but instead we had more sampling error? So let's double it to 10. What would we expect to happen now? Well, with more sampling error, would you agree that there's more uncertainty? With more sampling error, there's just like, ooh, I don't know now, right? Got a lot of sampling error. What are you going to have to do to try and capture mu? Well, you're going to end up having to draw a larger interval. All right? So when we increase our, well, we don't do it on purpose, but when sampling error goes up, all right, the confidence intervals, the accuracy stays the same. We'll still keep it at 95, but in order to have that 95% probability that the interval includes mu, in order to be able to say that, you're going to have a much larger interval size. So let's go ahead and do the calculation. Lower limit is 30 minus, now this one I can do in my head, 19.6, and that gives you 10.4. That's your lower limit. Upper limit will be 30 plus 19.6. That gives you 49.6. So now we're saying that mu is greater than or equal to 10.4 and less than or equal to 49.6. So in other words, we're saying that 95 times out of 100, mu is somewhere in this interval because we've drawn it correctly. Look what happened to the interval size. See how it went up? It went up because your sampling error went up. If you want to stick to the 95% confidence interval, that's fine. But you're going to have to make the interval size bigger, and that will happen based on the formula here. Your interval size is going to get bigger because with larger sampling error, we have more uncertainty. Okay, so we're going to have to draw a larger interval. Hopefully this is making sense.